Perhaps the best way to learn the auditing process is by watching someone go through and audit a smart contract themselves live. For this reason, we're going to be doing a series where I walk through and audit a smart contract for GMX key, which is a convex-like solution for GMX rewards. It makes the escrow GMX that stakers earn, as well as the multiplier points, essentially liquid with GMX key and MP key alternatives. And the contract that we're going to be auditing in this series is related to rewarding the LP providers for GMX key, and it's going to interface with the Uniswap V3 staker contract. So in this first episode, we're simply focused on getting context on the system, getting a high-level understanding of how each goal of the system is achieved in the smart contract. It is so important to just get context on the system before you start to dive in and get some findings and try to break things in the smart contract. And this is because once you do have context on the system and once you do understand how everything is accomplished in the system, you can very easily go back to some initial notes and thoughts that you had and very easily, very quickly either invalidate them or validate them as significant findings. And then after you've gotten this context, it's very easy to do a second pass through the code and now start thinking about trying to break things and noticing bugs and vulnerabilities that come up along the way. All right, but who am I and why should you care about my auditing process? My name is Owen, and over a year and a half ago, I founded Guardian Audits, and since then, we've audited hundreds of smart contracts and uncovered dozens and dozens of critical and high vulnerabilities. And my goal with all of these videos, and especially this series, is to take all of my experience from over 1,000 hours spent auditing smart contracts and distill it down and give it to you so that you can ultimately become a much better smart contract auditor than I ever could be. All right, without further ado, let's hop right into the first part of our audit of GMX key. All right, so like I said, this audit is going to be in multiple parts, and this is the first part. This is going to be all about just gaining context and understanding what the system is actually doing, what it's trying to accomplish, and how it's actually accomplishing it. So we've got our LP staker contract pulled up here, and I've only done a brief scroll through just to understand the scope of the audit, but I have not looked at each individual function. I don't know exactly what this contract is doing. I know from a high level that it is meant to simply reward the LPers for GMX key, and I also know that it is interacting with the Uniswap position manager and the Uniswap staker, so I have those code bases pulled up as well so that we can sort of look into them and gain more context on those dependencies as we go. But like I said, this is going to be literally just context gaining, and then in future parts, we're going to actually have a more thorough understanding of the system, and we're going to get to the fun part, which is bending things and finding knobs that we can use to exploit the system and find potential vulnerabilities and bugs. But really, the first part is all about gaining context and just understanding what the contracts are doing as fast as possible and getting a holistic view of the design of the system. Okay, so the first thing I like to do is come and minimize all the functions and just expand this, and we can see I've got all of the functions basically rolled up here, and this is so that I can easily see from a high level just everything that's going on, what the design is, without getting sort of overwhelmed with the code that's actually written inside of each function. Okay, so I can see here we are relying on the position manager NFT. We've got the staker here. This is going to be what I assume to be the Uniswap V3 pool. And then here's token 0, token 1. And then we have a reward token that I'm assuming will be getting paid to the LP stakers. We have an ID to owner, so I'm assuming what's going to be happening is we're going to have an NFT that I, as an LPer, I transfer my Uniswap Position Manager NFT to this contract, and then this is how they're going to account for, what we're holding from whom. And then we have this tokens staked, which looks like it's an address to a list of UNT 256. I don't know what this is going to be off the top of my head, so this is something that we will pay attention to as we are going through. We have a list that is 5,200 long of incentive keys. We'll just check out this struct. This has a reward token. We've got the pool and a start time and end time and a refundee, which I assume is if the incentive doesn't get fully paid out within this time, we'll go to the refundee. If we go back, there's a comment here. So we have incentive registered once a week for a max of 100 years. So presumably 5,200 times 7 is going to be roughly, I think, a little bit less than 100 years in days. Okay, we've got this mapping that's pointing from a uint 256 to what is a staked index. So we've got a first and a last. I'm assuming this is going to be potentially IDs of position NFTs to when they were staked. Probably, this probably refers to incentives, weeks, perhaps. We'll see. The current index, which I'm assuming is going to be applied to the incentive keys, a min liquidity, which is probably the minimum liquidity you have to be providing to actually stake and get rewards. And then we've got a rewards mapping in here. So it seems like the contractor is going to be pulling rewards from Uniswap from the staker and then also recording those rewards in a mapping in this contract, and then the ID to owner. The owners here are going to be withdrawing the rewards via the accounting from this reward mapping. That's what I assume. Okay, so we've got some setters. I'm not really interested in looking at these right now. I am somewhat interested in this one since I want to know a little bit more about the incentive key. Okay, so when we set, we have a key that's already made, and it has to be the start time, so it has to have already started, and it can't have ended. Okay, and the reward token has to match what's in here. It has to be the pool for the right pool. Okay, and then we're getting the code that corresponds to this key. Okay, so it has to be an incentive that actually has rewards, sure. Okay, then this looks a little suspect here that we're doing this looping back around. So I'm going to leave a tag here that says, I'm literally just going to say this is sus, and we'll basically come back to this later once we understand more of the system and see how this could be sort of manipulated. Okay, then we're just going to increment it otherwise, and then the incentive keys. So we essentially instantiate the next slot in this array, and then we update the current index. And it seems like they're going to have to do this after the incentive is already started. So I'm wondering if it's possible for people to stake for this incentive key without even going through this LP staker, and I'm wondering if there's anything interesting that can come of that. So that's another thing I'm just going to write down. So what if people can stake without going through this contract? So we'll see. Okay, so next I'm just going to get a high-level overview of the different functions that we have here. So we've got a method to unstake token once. Interested in why the key count is needed here, we'll see. Extend staking. We have an extend staking and unstake tokens. Deposit and stake LP token. all sorts of combinations of staking and unstaking and depositing and withdrawing. Of course, okay, a claim all reward, and I'm assuming if we go in here, it's going to be somewhat simple. Okay, not going to get into that too much right now, but it looks like essentially from a high level, we're reading this rewards mapping and transferring it. I'm assuming this reward is going to get incremented when we get stuff from Uniswap. So I'll close this back up. We've got collect fee. I'm assuming this is going to be actually going and getting the fee from Uniswap. We've got some view functions now. View on ERC 721 received, and then here are our internal functions. Okay, so now I'm looking for just high level jobs to be done of the system. So first of all, it's an LP staker. I need to know, one, how do we stake? Two, how do we unstake? Three, how do I collect rewards? And let's see, is there anything else here? There's collecting fees, of course. So with my position, I want to be able to collect fees from my Uniswap position. And I'm interested what the on ERC 721 received. Okay. This is basically just a stub function just so that we could be safe transferred ERC 721s. And then I'm going to write down here extend staking because this is something I see and I actually don't understand exactly what extend staking is exactly doing right now. I assume it's extending staking somehow, but I don't know in what capacity. So I'm going to start off first. I want to understand how do we stake and what does that really look like? So let's see. We have a deposit and stake LP token. This is what I've got my eyes on. Is there anything else? We've got unstake, extend, withdraw, and view stuff. Okay. So I'm going to go into this deposit and stake LP token. Okay, so we're getting the current incentive key, and then we're going to go through and loop the token IDs that are provided. And then I'll just note here that first of all, we've got initialized default value, we've got uncached token IDs length, we've got could do unchecked plus plus I. So just some optimizations for this loop. It's just small minor gas things. Okay, so we're getting the token ID, and then what are we doing? We're getting the liquidity. Okay, so we're just going to basically do an assertion, a check on the liquidity of the position has to meet the min liquidity. Let's see, what is this doing here? We have the position manager. So the owner of the token ID has to be calling this. Seems reasonable. Yeah, validate requested by owner. And then we are transferring that NFT to this. So this contract is taking the NFT when we deposit. Okay, we've got the ID to owner. So this is that accounting for like, okay, who sent the NFTs? Okay, so person who sent this has this. Tokens staked. We push the token ID into the token staked. This is for the owner. Oh, I see. Okay, so if we go to tokens staked, yes, okay, so this is a mapping of the owner to the tokens they have staked. I wonder why they need this particular list. We'll see. We'll see why they need this, but so when they say staked, it isn't necessarily staked in Uniswap yet. It is just been deposited into this contract at this point. And then what we're going to do is we transfer it from this contract to the staker with the, okay, yeah, this token, and then for the key, which is the current incentive key. So it gets essentially deposited and staked with Uniswap. And the staker for this incentive key, let's see what this comment says. Yeah, deposit and stake. And so let's check out the staker for a second. I assume we want to look at the on ERC 721 received. Here we go. Okay, so when we receive, then we create the deposit and set the owner to from. Okay, so if we just check out, we could confirm this for ourselves. If we just go to, what I want to find is just ERC 721, so let's go here. When we do a safe transfer, we're going to do this, and here's where we call this, right, so message sender is the first from, if we go back up, from, okay, so the from is the same from there, okay, just to be sure. Okay, so the owner is, this contract is the LP staker when we do this, because we've transferred it from the original owner to the LP staker, then the LP staker transfers it to the Uniswap staker, and so the LP staker is the owner as far as the Uniswap staker is concerned. So let's see what we do. We get the tick lower and the tick upper, so the bounds of this position. What do we do with this? We create the deposit. Okay, and this is stored on the deposit. Number of stakes is 0, so at this point we haven't staked. And then, okay, so now we're staking. Okay, so if the data is a particular length, I'm assuming that this, I'm just gonna assume right now that, you know, this is the length of a single key, so a single incentive key encoded. Okay, then we're gonna decode it in stake token. So let's see. I'm gonna stake a token in the Uniswap v3 staker. We get the pool, we get the tick lower upper liquidity. We're going to use all of this. Let's go all this validation. Okay, sure. The incentive is active. Get the ID. Okay, so there has to be some rewards that ought to be claimed. And let's see, stakes, token ID, incentive ID. Okay, so I guess this is going to be a measure of if the token is already staked. So I guess if there's liquidity corresponding to this token ID for this particular incentive, then this is going to be non-zero, and then you would have already staked. So let's see. Okay, the pool has to match the position. Right. So I make an incentive key, and the incentive key maps to an incentive program for a particular pool, and then all of the stakes have to essentially be positions from that pool, which makes sense. Okay, so on my deposit, I see we have a number of stakes. So it seems like when I deposit a token, it could be staked for multiple incentive programs from what it looks like. Okay, and then of course, for this particular incentive, we staked just now, we staked something, and we know that this is the first time that this particular token ID is staked. So this is safe here. So, okay, so snapshot cumulatives inside on the pool, seconds per liquidity inside. X128. Not going to be attempting to understand the Uniswap stuff too deeply on this side, as long as it's not a really fundamental part of the API that we're interacting with. But it will be good to understand exactly what's meant here when we talk about seconds per liquidity. I assume this is some way to, figure out exactly how much rewards ought to be distributed based on the size of the position here and where exactly this is relative to, where's the active trading and stuff like this. Okay, then we've got some cases here where basically what we're doing is it looks like we're just writing to stakes, and then so if the liquidity is a 128 bigger than a UNT 96. Okay, so we're doing something interesting here with if there's no overflow, then just give it the max, and then this is the overflow, and I assume this is going to be the 128. Yeah, okay. But anyways, in the normal case, okay, so we just set the seconds per liquidity and then the actual liquidity on the stake. And so if I wanted to add more liquidity to my position or take some away, I would have to withdraw it from the staker. And so that's where I'm assuming they're safe from, somebody making a stake, and then you assign it to be the liquidity of the position, and then they can decrease the liquidity of the position. It doesn't match up, right? So they had better always be able to, you can only stake if you are deposited into the system, right? So I have to first deposit before I can stake. Okay, and that's how we are interacting with the system there. Okay, so what we do here is we transfer from this LP staker contract to the Uniswap staker contract, and we are staking for this particular incentive key, which then means that we'll end up going down here into stake token. And then the important part of what happens here is really we're going to increment the deposits for this token ID and increment the incentives for this. Okay, so the number of people who deposited for this key here. And then we're going to create the stake here for this particular token and this incentive. And we know that that's going to be unique because you can only do this once, because they're going to be checking this. And I'm going to assume that you can't have a position that's just going to have zero liquidity to be safe. That's going to be something that would be good to verify. If it did, we might just have, an interesting knob to be able to twist and see if we could have that affect the LP staker in some interesting way. But my thoughts are that they're not going to allow some position to exist with zero liquidity. Okay, so ultimately we create the stake, and then I'm assuming this variable here is going to be used, and probably this one as well is going to be used to compute the rewards that we get from Uniswap. Okay, so after we've basically taken the NFT from us, the owner, we give it to the LP staker right here, and then the LP staker does some accounting, and then they give it to Uniswap, and then now, let's see, what do we do here? Staked index, token ID. Okay, so originally when we first deposit this staked index, this is the beginning and the ending. Yeah, the first and the last. Okay, so the first is the current index, and the last was the current index when we were first taking. Okay, so we set indices. Okay, and that is how we deposit and stake LP tokens. So I've basically checked that off. I've walked through and I've understood how we deposit into the system, how we stake in the system. Now I want to look at how we unstake. And so it looks like, okay, so there's this function here, unstake and withdraw, LP token. Let's see, there's also unstake tokens unstake token once. These are all external. So there's a few functions here. First, I'm going to sort of open up this one. We're going to check out unstake and withdraw LP token. It looks like it's actually applying to multiple tokens. And then I'll just make the same note about loop optimizations. There's also, something minor to be said about could use custom errors. Another minor gas optimization, but okay. Okay, then just skimming over, see we check if reward is greater than 0, this is a uint. So another super minor gas optimization is to check not equal to 0 rather than greater than for uints. Okay, so let's understand what's happening here. Okay, so first of all, the person who is trying to withdraw had better be the owner of this token in the loop. Then we unstake token with all incentives. We'll see what exactly that means in a second. I'm not going to dive into this. I want to get a high level view of this function. Let's see what the comment is. Unstake from all the incentive keys. Interesting, right? So we can stake for multiple incentive keys, and that makes sense if we're going to be staking. If we have these incentive keys over time, we have one each week, right? We have registered once a week for a maximum of 100 years. Then if I stake for 50 weeks, then presumably there's going to be, I'm guessing, 50 different incentive keys that I'm going to be registered for. That's my hypothesis. Okay, so we get the reward, and then we delete the reward, and then we send it. So this had better be fully updated by now. I'm assuming that's going to happen in this function. If it isn't, then we might have a problem. Okay, let's see. So then once the reward, that's interesting, the reward's paid. Okay, so we pay the reward, and then we're going to be actually withdrawing the token from the staker, and I have to figure out exactly what this ends up meaning. Maybe this is the key, like if you're supposed to unstake from a single key, but we've already done that, so we'll see in a second. What is this? Withdraw token from staker, right? Delete token from staked. Remove records from staking for staking. Delete ID to owner. Okay, that makes sense. And I'm interested, so where is the actual withdrawing of the LP token happening here? Oh, of course, right here, right in front of my eyes. So it's not that we withdraw it to this contract. We withdraw it, I'm assuming this is so we send it to the message sender, which is of course the owner. Okay, so I'm going to quickly just have a look at this withdraw token, because I think this will be fairly straightforward. I'm not gonna try to understand everything immediately here, but withdraw token. Okay, so of course this is the 2. Cannot withdraw to the staker. Okay, we get the deposit. Okay, so at this point, this makes sense, okay. At this point, the number of stakes has to be 0. And so this is why we need to, of course, unstake from all of the incentives. I'm interested, actually, I'm interested. What if, I don't know if this is going to be possible. Yeah, I really don't know if this is going to be possible, but what if I could stake for something else, like something that's not applicable to this system? So they're going to have all of their keys, and then they're going to unstake for all of those keys when they call this. But what if I could stake for, let's say, another key outside of the GMX key system? And then, so if I had staked for something else, then potentially, if say you were able to do that, then you wouldn't remove all of the number of stakes with this call here, and then you wouldn't actually be able to withdraw it all until that last stake was removed, which might not be possible if you gave ownership, if you gave custody of this deposit to this LP staker contract. But then that begs the question, how are you going to get it staked for something else? But we'll see. We'll see if that's a possibility. But that's just something I'm thinking about as I'm first reading this. And then we see, okay, so is the owner the message sender? That's right. Okay, and the owner is going to be this LP staker. Okay, then we delete the deposit. We've got it cached here so that we can emit the event, and then we just safe transfer from. Okay, so the token ends up at the 2. Okay, and then again, just to confirm, if we go to our ERC 721, this check, okay, so if it's not a contract, then it will be able to just transfer. And then, of course, it's going to be with data. Okay, so that's what the data is. It's just going to be passed on to whatever the contract could be if it were sending it to a contract. So let's talk about reentrancy, because I'm withdrawing it to this message sender here. We're going to end up calling the message sender with the on ERC 721 received. So this is something that's a bit scary because, yeah, this is, so we're doing, okay, thankfully we delete the rewards, but then, yeah, I think there could be something potentially quite bad here that I'm going to, I'm going to write, I think, so reentrancy here, especially with all of these getting written afterwards. The rewards have been deleted though. That would be quite an easy one if I were able to get the rewards and re-enter. But we'll dig into that one more after we understand the system a bit more. Once we get more context, we're going to be able to see everything that can come of this and immediately sort of point out and be like, oh, yeah, that's going to be critical. Now we sort of walk through that unstake and withdraw. I'm interested in these other unstake functions here. Okay, so we've got the same loop comment. I'm not going to write that every single time. We've got unstake token with past incentives. So I'm assuming this is applying to past incentive keys. And then let's have a look at unstake token once. Okay, so this takes a single token. We get our staked index. Okay, and then let me just check when we're depositing the staked index. Okay, so it's this beginning and ending, so the first and the last. Okay, so let's see what happens here with the index. So we get the first index. The first has to be less than the current. Then we get the keys. So then the first incentive key, we unstake for the first incentive key. Okay, I'm going to look at this internal function here. So again, we get the staked index. The first has to be less than the last. Okay, so that means that this has to get updated after it's first written. I have yet to see where it gets updated. I guess we're about to see. So let's see. The first, interesting. So the first gets incremented by 1. Okay, I suppose because, okay, if I, let's see, yeah, the first, so I suppose, are we unstaking for the first? Let's see, what's the key here? Like, it makes sense if we're assuming that the key is from this first, and then it's like, okay, you withdrew for the first, you unstaked for the first, so we're going to tighten that range a little bit. Okay, then if liquidity, which comes from, okay, the stakes for this key, the liquidity, if there is liquidity, so I guess that's almost like, does the stake exist? That's what it seems like. Then we unstake token and we claim reward. Okay, and really quick, claim reward, what does this look like? We just call this claim reward. Okay, so could assume that this is just going to take, rewards that have been accumulated. They do all of that, semi-complex computation with the beginning and ending of the position and all of this. They give us a number and it ought to get transferred to this LP staker contract, and then that gets incremented on this reward mapping. Okay, so that's, okay, so unstake token. I'm actually interested in what the staker does for this unstaked token. Okay, so we get this key, we've got the key here. We unstake it for a key, and the key is the one that's passed in. Okay, that's interesting. Okay, so anybody's allowed to unstake the token if the incentive has ended, which actually that seems like a knob that we're going to be able to use in the system. So can this cause unexpected consequences? Definitely something we're going to look into once we understand the system more. Okay, so we get the incentive ID, and then, all right, we're doing the computation here. We get the reward amount. We update the accounting here. Increment rewards. Okay, right. So when we unstake, we increment the rewards. And then later on, this is what we're going to be pulling from the Uniswap staker into the GMX key staker. And then ultimately, you'll be able to pull it from the GMX key staker. Okay, we clear out the stake. Got it. Clear out the stake. No more liquidity. Do we do anything for the deposit? Yeah, the deposit, just the rewards. Don't we have to change? Okay, right. Here we go. Yeah. So the number of stakes get updated. Okay. Makes sense. And then we claim the reward, pull those tokens into this contract. So when we talk about unstaking for a key, yeah, this part's still a little fuzzy to me. Like, it would make sense to me if this key was always the first, then it makes sense that you're able to just remove that, the last part there, and increment the first. But how do you know that this key, so I guess let's go back to where this is used. It is the first, okay. So the key is the first, at least when you call it from here. When you call it from here, let's see. So from here, it looks like it's not going to be the first. Unstake token with exclusive last index. So incentive keys, where is incentive keys? This is a storage variable, right? Okay, yep. These are the actual incentive keys. Okay, I see. So is it going to, okay, we're going from the first to the last. So as we go through this list, we start off with the first for this token ID. So we get the staked index, and then, okay, so we're talking about some exclusive last index, something like this. Okay, so we start at the first, we go to the exclusive last index, and we unstake along the way. And so what this is going to do is, like, and for each of these keys, each of these week-long incentive programs, each of these incentive keys, as we go, we unstake from Uniswap v3, we get the rewards for that week-long incentive program. We bring it into this LP staker contract, and then that all gets compounded in the rewards mapping. Okay, and then so what we're doing is we're shortening the index. Yeah, the index is going to become, so this staked index, the first is getting closer to the last, and in this loop, the last is going to end up being the exclusive last index. So this, the first is going to end up being this exclusive last index in this case, because we're going to increment it up to that point. Okay, then I want to have a look at, what was this other function? So we had unstake token once, unstake token with past incentives. So let's see this. We've got the token IDs here. And okay, so for each token, we're going to unstake token with past incentives. And we're given a key count, and the user can specify any key count here. So, okay, so we're getting the exclusive last index. Oh, interesting. It's the last plus one. If the current index is less than this, then it equals the current. Okay, so you can only claim up to the current index. That's good. And then we do this function, the exclusive last index. Okay, so what's this, the key count here? Okay, was this the function we were just looking at? We were jumping around a little bit. Okay, this is that function that we've been looking at. Okay. Okay, so what's happening here is the key count is like, okay, how many keys do I want to claim for? How many of these past keys, past incentive keys? Okay. So what happens here, key count cannot be equal to if it's not the max. Okay, and then the range, if the range is greater than the key count. So if we were to do this range, and it would be claiming from more keys than the key count, which is the amount of keys we want to claim, then we set the last index to go from the first to the first plus the key count. So of course there's some interesting, off by one potential cases that I'll have to work through, but just getting a high level understanding, I'm just going to go with this. And then, okay, so and then we do the loop and we unstake for keys. Okay, so that makes sense. So it looks like I have a good understanding of how we unstake in this contract, and to be honest, also how I collect rewards, right? Because I know that we're going to be pulling rewards from Uniswap into this function, into this contract, and then I can go ahead and there's a function to claim all rewards here for tokens. Ooh. Okay, so there's some more interesting stuff here. Okay, so maybe there's a little bit more to understand for collecting rewards, but we're gonna cut it here for the first time. I think staking and unstaking and depositing into the system and withdrawing out of the system, that's a great place to stop. Now we have a great working mental model of how we go into the system, into this LP staker, and then how we go from this LP staker to the Uniswap staker, and then come back out and get the rewards accumulated in the LP staker contract. So next time we're going to understand what's all of that, what's that new interesting stuff about collecting rewards, and then how does collecting fees from my position work? I assume we're gonna need to get the NFT back from Uniswap somehow or something like this. And then also, what is this extend staking? What is that all about? So, okay, we're gonna figure that out, and then once we have all of this context, then we're going to be able to come and do the fun stuff, which is looking into that possible ERC 721 reentrancy, seeing if there's any off by one errors in the looping, and then seeing, of these knobs, of these comments that we made in the staker, are there any of these interesting edge cases in the staker that we can leverage to ultimately be able to exploit and cause some unintended consequences in the LP staker? All right, so I can't wait to get into these next parts here, and I'll see you in the next one.